Okay, for example 7, a velocity time graph in the figure below shows the motion of a lift. Describe qualitatively the motion of the lift, and then we have to sketch a graph of acceleration against time, and then determine the total distance traveled as well as its displacement, and then find the average acceleration between 20 to 40 seconds. Okay, so I've written down the qualitative explanation, which is this part here. So where do I get the numbers? This one is from the gradient of the graph lah. Okay, and then now we can do the acceleration against time graph together. So we know that the first 0 to 5 seconds the lift moves with a constant acceleration of 0.4. So that is from 0 to 5 seconds using this. So it starts here. Okay, okay, lepas tu from 5 to 15 seconds the velocity increases from 2 to 4, but the acceleration decreases to 0.2. So from 5 to 15 dia decrease pergi 0.2. Okay, lepas tu 15 to 20 lift is moving with a constant velocity of 4. Constant velocity means acceleration is 0. Okay, remember acceleration is 0 when constant, velocity is constant. And then from 20 to 25 seconds, lift decelerates, meaning the acceleration is now negative. So it is decelerating at constant rate of 0.8 lah. So we can draw garis 0.8, 20 to 25 seconds. Okay, lepas tu at 25 to 30 seconds pula lift at rest, so there's no acceleration. And then after 30 to 35 seconds pula it moves downwards with a constant acceleration of 0.8 as well. Okay, so lift and then 35 to 40 seconds pula it moves with constant velocity. Again, constant velocity means acceleration is 0. Okay, and then from 40 to 50 seconds the lift decelerates at a constant rate of 0.4. Okay, so that is your graph for acceleration against time graph. Okay, so sambung lah sikit sini tu. Garis lah semua ni, okay? This, like this, like this, like this. Okay, so that is acceleration against time graph. Now dia suruh kita cari total distance traveled by the lift and its displacement. Okay, this one let's do it here. Total distance traveled. Okay, so we know that for V against T graph, we know that we can find the total distance traveled by calculating the area under the graph. Which is this gitulah. Okay, so let us label each area. So this one I would call area 1. This one is area 2. This one is area 3. This one is area this one is area 4. This one here is area 5. Okay, so this one is trapezium. Okay, so we can then find again so we can find the total distance traveled is equal to area under the graph, which is equal to A1 plus A2 plus A3 plus A4 plus A5. Okay, So let me just write je lah juga. 2, 5 plus 1 over 2 trapezium punya, 2 plus 4, then 10 plus half, 5 plus 10, 4 plus half, 5, 4 plus lagi last half, 15 plus 5, 4. Then you'll get the total distance to be 115 meter. Okay, yang last question dia minta apa? Displacement. So for displacement, have to write here lah. Okay, so for displacement can also be equal to area under the graph. However, we are considering the direction, because displacement is a vector, and since we are considering the direction, A1, A2 and A3 will be the only area that is positive, while A4 and A5 will be negative, because they are because we are considering the direction. Okay, so just calculate that. You'll then get displacement to be 15 meter. Okay, sorry, this is not D, this is C juga. Okay, so for question D pula, apa dia minta? Calculate the average acceleration. Okay, so the average acceleration is delta V over delta T. Okay, dia dah cakap kat what period. Okay, so we are looking at 20 to 40 seconds. So 20 to 40 seconds, this part. Okay, so kejap. Yeah, betul lah. So 20 to 40 seconds, final is -4 minus dengan 4. Lepas tu, let me just write -4 minus 4 over dengan the time, which is 40 minus 20. Then you'll get the average acceleration to be -0.4 meter per second square. Okay, so that is on example number 7.